You are welcome to today's lesson. We are continuing our discussion on direct variation, and this is the part 2 of our lesson. To be able to understand this lesson, make sure you watch lesson 1 and 2 in previous videos. And don't forget to subscribe to this channel to receive updates anytime a new lesson is uploaded. Now, what did we say about direct variation? Remember, we said in our lesson 2 that direct variation is a situation in which two quantities increases or decrease at the same rate. Now let's continue by looking at some illustrations under direct variation. In this illustration, z varies directly as y, and z equals 8 when y equals 4. In our first question, we have to find the relation connecting z and y, and secondly, we have to find z when y equals 10, and lastly, we are finding y when z equals 12. To solve this question, we need to know the symbolic interpretation of the mathematical statement z varies directly as y, and this can be written symbolically as z followed by the variation of proportional symbol, then y, and this can be written as an equation z equals k multiplied by y. In our first question, we have to find the relation connecting z and y. This also implies that we are finding the law of variation, and so in this question all we need to do is to find the value of k and substitute it back into the equation to derive the law of variation, which is the relation connecting z and y. From our question, z equals 8 and y equals 4. To determine the relation between z and y, we need to know the value of k, which is our constant of variation. To determine our constant of variation, we need to substitute the value of z, which is given as 8, and the value of y, which is given as 4, and this becomes 8 equals k multiplied by 4, which can also be written as 4k equals 8. Dividing both sides will give us the value of k to be 2. Now, how do we generate the relation between z and y? Now, we know the value of k, which is our constant of variation, to be 2. So wherever I see k, I'm going to substitute the value 2. And this equation now becomes z equals 2y. Therefore, the relation connecting z and y is given as z equals 2y. And this is also called the law of variation for this question. In our second question, we have to find the value of z when y is given as 10. How do we do that? We need to know the law of variation for this question, which is the relation connecting z and y, and that was found out to be z equals 2y. To find the value of z, substitute the value of y. Wherever I see y, I substitute the value 10, and now this becomes z equals 2 all multiplied by 10, and this becomes z equals 20. Wherever y equals 10, z is also 20. In our last question, we have to find y when z is given as 12. In the same way, we need to know our law of variation for this question, which is also the relation connecting y and z. And this was found out to be z equals 2y. So wherever I see z, I substitute the value 12. And this becomes 12 equals 2y. Dividing both sides by 2, we are going to obtain y equals 6. So wherever z equals 12, y equals 6. Let's look at another illustration. If d varies directly as f, and f equals 120 when d equals 30, find the value of f when d is 156. To solve this question, we need to know the symbolic interpretation of the mathematical statement d varies directly as f, and this can be written symbolically as d followed by the variation of proportional symbol, then f, and this can be written as an equation d equals k, which is our constant of variation, multiplied by f. And in our question, f was given as 120 when d equals 30. These two values can help us determine the relation connecting d and f, or the law of this variation. And to determine the law of this variation, remember we need to know the value of k, which is our constant of variation. And to do that, wherever I see d, I'm going to substitute the value 30, and wherever I see f, I substitute the value 120, and this becomes 30 equals k all multiplied by 120. And to simplify this, we have 30 equals 120 multiplied by k. In the same way, dividing both sides by 120 will produce our constant of variation to be 1 out of 4. Knowing our constant of variation, we can now determine the relation connecting D and F. That is the law of variation. The law of variation for this question becomes D equals 1 out of 4 multiplied by F. Knowing the law of variation for this question, which is giving us D equals 1 out of 4 multiplied by F, we can attempt our first question, which states that find the value of F when D is 156. Wherever we see D, we substitute its value, which is 156, equals 1 out of 4 multiplied by F. Solving for F, we multiply through by 4, and this becomes 156 multiplied by 4 equals 4 multiplied by 1 out of 4 multiplied by F. And so 4 and 4 will cancel out, and that gives us a new equation. F equals 156 multiplied by 4, and that will produce F equals 624. Therefore, the value of F when D equals 156 is 624. Kindly attempt this question and submit your answer in the comment section. The first question states that if T varies directly as the square root of X and T equals 12 when X equals 16, A, find the law connecting T and X, and B, find X when T equals 6. C also states that find T when X equals 64. The second part of the assignment states that if P varies directly as Q cubed and P equals 3 when Q equals 2, find P when Q equals 4. Kindly submit your answer in the comment section. Thanks for watching, and see you in the next lesson as we discuss the next type of variation, which is indirect variation. Don't also forget to subscribe, like, and comment on this channel.